Welcome students, welcome to Short of Sir classes. So this question is from ISI M.MATH 2022 and the paper code is PMA. So this solution has been prepared by the faculties of Short of Sir classes. So what is given in the question number 14, let R be a competitive ring with unity and AB is an element of R. Now consider the ideal where I equal to this inner product of AB. So and it is given xa plus yb where x is r and y equal to this element of r, and I square is given as summation of I equal to 1 to n a of I bi where ai bi is an element of I and n is a set of the natural numbers, belongs to this set of natural numbers. Then which of the following statement is not true in general? So we have been given this I is inner product of a comma b, so which is a subset of R, and this is ideal. Now this I is also a subset of, if you consider the option A, the A minus 5b comma b, this inner product which is equal to J, but we know that A is equal to A minus 5b plus 5b, which is 5.b, so which is an element of J. So I is, we can define the inner product of this as A minus 5b comma b. So this option is correct. So I have to find which of the following statement is not true in general. So what is the option 2 is given, that the option B. So we have this, so AB is an element of I as given, right? But AB is not an element of I square. So this option B is the incorrect option. Let's check with the other option also. So this option C, I square is a subset of I. So I square is a subset of R dot I, which is a subset of I, okay, as I is an ideal. So hence this I square will also be a subset of I. Now check with the last option, that is option D. So in D we have this I plus I is equal to I. So I is an ideal, that implies that I plus I is an element, is a subset of I. So let us take that X is an element of I. Okay. Then X equal to 0 plus X, which is an element of I plus I. So we can say from here that X equal is an element of I, so it will be nothing but I equal to I plus I. Okay. So this option D is also true. So the incorrect option here is option B. Now question number 15 says that let G be a group of order 30 and which of the following statements is necessarily true. So this first option is given, that let G is abelian but may not be cyclic. So take G be a S3 and Z5. So S3 is a symmetry of order 3. Okay. So notice that G is not an abelian. and it is not even cyclic, right? So A and B, these two stands wrong. Now G cannot have more than 7 subgroups of order 5, so this is the option C is given. So number of subgroups 5, number of subgroups of 5 is given by 1 plus 5k, that will divide 6. Now if k equal to 0, then it has one subgroup of order 5, right? So it will be 1, which is, it is said that G cannot have more than 7 groups of subgroups of order 5, so which is less than 7. So this C is the true option. And also let's check with the option D, that the G can simultaneously have one subgroup of order 2, 5 subgroups of order 3, and 6 subgroups of order 5. So in the option D, we can write that G has one subgroup of order 5. So J is also not true, D is also not true. So our correct option here is option C.